All right, so for this video, this is the 2.8 task. This is the beginning of it. This is only questions 1 through 5. It's a little bit lengthy, and I'm going to try and shorten it up as much as I can. If you need to, go back and rewatch it. The very first question, it talks about how we want to expand our business and we want to offer a lot of different things to people, but it says some people order things that are exactly twice as big as a regular block that has sides that are 1 inch longer on one side and 3 inches on the other. Well, I'm going to back up a little bit. At the very beginning on day 1, I said I'm going to refer to this particular figure, and I'm going to refer to the area, and that area is going to be equivalent to the function of x squared. And we're always going to refer back to that, so much so. Well, we've seen in the past that we've taken this area and we've added something to one side and we've added something to the other. We talked about doing it in the same fashion, which would be a perfect square, or hey, 3 to one side, 2 to the other, which makes it a rectangle. But what if I took this figure and I wanted to draw one that was twice that size? What would I do? Think about it. I wanted to draw one that was twice that size. Immediately, people are thinking, well, gee, I need to expand this. No. All you need to do is draw a second figure. I have x squared and x squared. And how many do I have? This represents twice the size of my original. Think of it that way. So now in question number 1, when it says I want 2 of an original block that has been expanded 1 on one side and 3 on the other. Here is my block, x plus 1, x plus 3. Well, great, x plus 1, x plus 3, as a product, right? So here's my figure. But I want one that's twice this size. Yes, I would draw another one. That's how it would look. Okay, so how do I express it in written form? I put a 2 in front of it. It's that simple. Now, how can I express this differently? 2x squareds, 4x's here. So if I have 4x's in this one, I have 4 in that one for a total of 8x's. And I have 3 single unit squares here in this one. 3 and 3 is 6, so plus 6. There are 2 expressions for the area of this model. Go down to question number 2. It gives you a bunch of diagrams here. Okay, I didn't draw all of them, but if I want to draw one, now I'm going to do this a little bit different. I'm going to write the standard form question first. Based off of these 3 squares, I should have 3x squareds. How many x's do you count? Everybody says 15 x's. How many single unit squares do you have? Everybody says, if I count, 18. Okay, great, no problem. But how do I know how many x's go to this one and this one and this one, and how many single squares go to this one, this one, and this one? Well, if I look at this as 3 different pieces, 15 divided by 3 is equal to 5. So I have 5 x's that go to each one. If I take and count all these up, which I had 18, 18 divided by 3 is 6. I have 6 single unit squares that go to each one. So I have 3 x squareds, I have 5 x's, and I have 6 single unit squares, right? This represents one of them. This tells me I have 3 of them. But if I take this 5, how do I know how many x's go to one side and how many x's go to the other side of one of my models? Is it all 5 on one side? Is it 4 on one side, 1 on the other, 3 on one side, 2 on the other? How do I determine that? Right here. Take this, and you're going to factor. Factors of 6 that give me my middle term. This is what, I'm going to break it down even further. Essentially, I took this and I divided it by 3. I took my original and I divided it by thirds. That's how I got what each one was, right? We did that over here. Well, I'm going to take this even further and break it down into x plus something and x plus something. What is that? What factors give me positive 5 when I add, but when I multiply, give me positive 6? The answer is 2 and 3. So x plus 2, x plus 3. Here's the factored version. Here's the entire version. Again, we're factoring now. Something a little different. Question 3, it says, what do you notice when you compare these two equations right here? The comparison is A tells me how many diagrams, or how many diagrams in the model. Right? So here, the 3 told me I had 3, the 2 told me I had 2. Okay, so move on to question number 4. It says, optimize lots of new orders, use diagrams to help you. Well, I don't know about you, but I don't want to draw 2 diagrams, I don't want to draw 3 diagrams, I don't want to draw 5 of them, so I have a solution for you. We're going to draw 1 and I'll show you how to do that. But how do I break this down so I know how many go in each model? Well, here I'm going to divide by 5, but I'm going to divide by a greatest common factor. X is also involved. So when I divide by 5x, I get x plus 2. You're going, well, gee, how do I tell how I always start with a regular x, but how do I know how much to expand? Think of what this is saying. This is 5 times x plus 2. I can multiply in any order I want. The number of diagrams I should have, how much did I lengthen one side by? Everybody says 1. I don't know why. This is just x by itself. I did nothing to one side. The other side, I expanded it by 2. There. Nothing to one side, 2 to the other. Here is one model. How many of these do I have? So I'm going to multiply times 5. This one times 5. This tells me how many of these I should have. So now when I come down here to question B, I should have 3 of these. Well, gee, I have to know what to do to one of these, but I should have 3 of them. Okay, so let's figure it out. If I can, I'm going to divide everything by thirds. So 3 times x plus 21 divided by 3 is correct. 36 divided by 3 is correct. Now, I have 7 x's for one of my 3 diagrams. But again, do I do all 7 on one side, 6 on one side, 1 on the other, 4 on one side, 3 on the other? I don't know. Factors of 12, this is what we were working on the other day. Factor this right here. Factors of 12, 2 and 6, 3 and 4, that add to give me 7. The only ones that work are here. So 3 times x plus 3 times x plus 4. So 3 on one side, 4 on the other. X plus 3, squeeze it in there, x plus 4, sorry for the, okay, right there. I have 3 of these. Why draw 3? All right, draw 1. I hope you can see that, because if you can't, then I'm going to be kind of mad. Yeah, you can see that. All right, moving on. Let's try the others. Now what looks different about these is I have negatives, okay? So that's going to take some thought process here. Well, I'm still going to divide everything by 2 if I can. 2, 2, 4, yes, everything's divisible by 2. So x squared plus x minus 2. I'm going to have one model that I'm going to focus on, but I have 2 of them really, so times 2. How do I factor this? How do I break it down like this? Factors of 2 that add to give me my middle term. Well, now you got to stop and think. I need a negative c value. The only way I get a negative c value is if I have one positive term and one negative term, because they have to add to be positive but multiply to be negative, right? So it's going to be plus 2 and minus 1. So plus 2 minus 1. There's my factors. So x minus 1, x plus 2. Remember when we drew these, how we determined whether it's positive or negative? The slashing, so that tells me it's negative. Right there, I'm done. Same with the next one. Divide everything by 2 if possible. The first several of these questions are going to be easy. We're going to be able to divide everything by 2. So minus 5x plus 6. Again, I have 2 of these. I'm going to make note of that. How do I do this? Factors of 6, 1 and 6, 2 and 5. I want a minus 5, but I want to multiply them to get a positive 6. Okay? So I need to have something. Well, I can say minus 6 plus 1 is negative 5. And I can also say minus 2 minus 3 is negative 5. So which one is it? But remember, this is a plus. I add them to get a negative, multiply them to get a positive. The only way I can multiply and get a positive is if I have two negatives. So x minus 2, x minus 3. So here's my factors. Well, gee, minus 2, minus 3. So what do? I slash one way, I slash the other, and you have the x in here, which indicates it should be positive. Two other things, okay? Two other things, just to give justice to this, so that you see everything that we did in class for those of you that might not have made it here. What do you notice about this question, the last one, E? It has no middle term. Well, I still divide it if I can. So 3x squared minus 9. Yes, it has no middle term. When it has no middle term, that tells me my factors have to be opposites of one another. So I'm going to go ahead and factor 9, 1 and 9, 3 and 3, and what are the only factors that I can choose that are opposites of one another? Positive 3 and negative 3. These will cancel the b term out. So draw your model. Okay? Add 3, subtract 3. Now I didn't subtract 3 here, but I can show that. Subtract 3. There you go. There's my model, and times 3. Now the last question, question 5, this one gets us to kind of think a little bit differently. All I'm going to do is label each of the sides of this original equation. So I'm going to start with this one right here. How would I label this side here? You should look at it and say, gee, I can label this as x plus 1. Yes. Okay? Or its height. How would I label its width? Its width is labeled as x. Okay. What about this piece over here? Well, I already know based on this back here that this height is x plus 1, but what is its width? X. And then what about the piece I left off? The piece I left off is right here. How wide is this? We already know it's x plus 1 high, okay? But how wide is it? It is 1 wide. So now when I look at this, how do I determine the length of this entire side? I simply add the sections together. X plus 1, or 2x plus 1. Here is my rectangle. Write it as a product. Equals x plus 1 times 2x plus 1. There's one way. How many x squareds do I have? I have 2x squareds. How many x's do I have? I have 3 x's. How many 1's? I have 1. Now, I should be able to convert from this form back to this form. Well, gee, I divide 2 out of everything. Yeah, it works if you can divide 2 by everything, but in this case, you can't. Okay, so how, well, somebody said, well, it's not factorable. What do you mean it's not factorable? Here's my factors right here. So this is what we're going to start to look at. Excuse me, what is the process of taking this, which doesn't look like it's factorable, and turning it into two sets of factors, which is x plus 1, 2x plus 1. Stay tuned, because that's what we're going to start talking about next week. Enjoy your time off.